Welcome to Mr. Wilson Live. It is the holiday, but learning still takes place on the holiday. So I'm going to be with you here today for about an hour. Today we're going to be looking at the life cycle of the mosquito. We're going to be looking at the Aedes aegypti, and we're going to be looking at the Anopheles. We're also going to take a tour down the lane of vector as it is. And of course, that should take us nicely up to an hour. How are you doing in your neck of the woods? I know that Powell was here early. I know that Barnett was also here early. And D'Souza is now here with us. Now, if you're joining us from distant land and you're not yet a subscriber, we do encourage you and invite you to come on over. Please be reminded to like, share, and of course, subscribe. And remember, after the show, leave me a comment. All right? Now, it is very important that we do all these stuff as they help the algorithm to find the show to send to other persons so that we can grow. Sanada Thomas is here. Whoa, welcome. Jawawan is here early. I thought about your country. I know that you're a hour ahead of us. Uh, Cheryl is here. Jennifer, I'm not too sure if I remember Jennifer. Jennifer sounds familiar, but I can't remember that part. Are you new, Jennifer? If you're new, welcome to the show. And if you've been here some time ago, forgive me. I encourage you to participate in the action. That's how I get to know students and, of course, remember the names. I'm not seeing Tanisha for some time. I've been seeing Otisha. I'm not too sure what's happening. They are there over in Guyana. And there are some other persons. I'm not too sure what's happening. I've not been seeing them. You want to make use of the show while it is available. We know we are now in April. It's the 2nd of April. So we have April, May, and the exams start in June. So we have just 2 months to go before we have to really seriously start tying up. So I'm going to say it again. Remember to do as many past papers as possible. Those are going to help you to better prepare for the exams. I do hope that you are studying, you are making use of all the resources that are available. Usually, I start the show with a really interactive session, a session where you have to play your part, and then I join in somewhere in the show, bringing you good news, as persons would have said. So, this evening, we're looking at disease. It's part two of the disease. We started out with types of disease or agents of disease, that type of a thing. We started out with that. Today, I want to start the show by looking at how pathogens are transmitted. So how pathogen get to move from point A to point B or from host A to host B, that's pretty much a type of thing that we're going to be looking at. Hi, Otisha. That's pretty much a type of thing that we're going to be looking at to start the show. Past paper, the multiple choice question, we have no doubt about that, that the multiple choice questions repeat. We have no doubt about that. However, as it were for the paper two, what they do is to help you to better prepare and understand what will be asked or what can be asked and how it should be answered. But we have no doubt the multiple choice questions repeat all the time. And by virtue of you asking that question, it is saying that you have not been doing any past paper, because if you were doing the past papers, you would have seen the number of questions that are repeated. You would have seen it. I mean, every year it happens for both biology and HSB. So we want to know quickly, I want you to tell me, we spoke about vectors. They are transmitting pathogen from host to host. Now, what are the other medium in which yes, I do pass paper. All right, beautiful. Thank you very much. All right, so I'm not sure for paper two. You might find a little paper two here and there that's repeated. Probably not the exact thing, but the multiple choice is usually very close to the exact thing. in certain paper too, some questions is repeated. Dear Jawawan is saying that in some cases. All right, good. So let's kick the show off. Welcome to you all, those who are here and those who are there. Remember to join us, like, share, and of course subscribe. That is how the show grows. And if you have not been getting the notification for my posts, it means that you subscribe but you did not hit the notification bell and selected all. If you did that, then you would have been informed whenever there is a show and whenever there will not be a show. We are still in lockdown in Jamaica. No one can go out like today's what Friday, so no one has been out on the road today unless you're essential service. But we are still here for school. All right. So here we go. We want to look at how pathogens are transported. I was hoping for persons to be putting that in the chat for me now. I'm not seeing that, but I'm waiting for everybody to participate. So we know that some pathogen they are transmitted by vectors. What are the other medium? All right. Sir, I'm essential service. Great. So why are you not at work, this Sosa? What you do this Sosa? You're a nurse? You're a police? You're a soldier? I don't even know who are essential. Who are the essential persons? I'm sorry. All right, so I am waiting on those. So we spoke about vector. I have said that already. Now, pathogens are also transmitted by food. The food that we eat, you could get food poisoning, that type of thing. We talk about salmonella and all of that. You could get a pathogen from the food. You could also get pathogen from water. It could be airborne. I want you to listen carefully. I have another question coming up. So we could get it from vectors. We said that. We could get it from food, insect bite, vector. So we could get it from vector, food, water. It could be airborne in that there's droplets in the air and you could probably inhale that or get wherever. And of course, you could get it from direct contact. You touch somebody, as was the great case with Ebola, right? And you could also have dust particles in the air, suspended particle. Pathogen could be transmitted that way. Now, there could also be contact or contamination with feces. These are pretty much the major ways in which a pathogen moves from point A to point B. So remember, we spoke about the different categories of disease. Now we are looking at the ways in which our sexual intercourse would have been contact. All right, so we say contact. Sexual intercourse could have been contact. That's contact pretty much. All right, so just quickly to go through that again, the takeaway here is that we have about 7 major ways in which a pathogen gets to move from point A to point B. We started out saying vector that we looked at in the last class. And I want you to tell me again what is a vector. And then we said that pathogen could also be transmitted or transported or moved from one place to another by food. Of course, it could also be airborne. It could be there in dust or in direct contact. We could have it through direct contact. It could be in dust particles. And of course, it could be as a result of contamination or contact with feces. So there are 7 good ways in which pathogens are transmitted. All right. With that said, we want to look a little closer at vectors. Now, we're going to be looking at 2 mosquitoes today, and then in further show, we're going to be looking at the housefly. All right. But today's show with the mosquito is going to be pretty interesting as we looked at the Aedes aegypti and the Anopheles. Now, what I want you to do, I'm waiting for that definition. Everybody's moving a little slow this evening. I'm not too sure why. I'm waiting for that definition for a vector. What is a vector? In our last class, you told me what vectors were. You told me what hosts were. And I want you to tell me again, vectors. We're looking at vectors today. So as you look for that definition to post for me, we're looking at some name vector, and we want to look at, of course, some disease that are transmitted by these vectors. The first one we could look at is the mosquito, being that one is topical for today. Now, the mosquito will be spreading things like yellow fever and dengue. Now, that particular mosquito is called the Aedes aegypti. Now, when I teach my students, I usually say to them, when we talk about these, dengue, these, dengue, right? And if it's not going to be the D's for dengue, as it were for your syllabus, it's going to be the Anopheles for malaria. All right? So Barnett is saying that a vector is an animal that transmits an infectious disease to human. But I want to find out in your definition if the vector is armed by the disease that is transmitted from one place to another. Let me know that while you define, we want to know that as well. Good. So we said now, let me just recap. I recap a whole lot. Mosquitoes, they are vectors. Mosquitoes are responsible, you know, for chickpea and sickpea. Mosquitoes are responsible for yellow fever. Mosquito is responsible for dengue, and mosquito is also responsible for malaria. Now, these are some that we will look at in our syllabus. Now, if we're talking about the Aedes aegypti, then that particular mosquito is responsible for spreading yellow fever, and it is also responsible for spreading dengue. So it's D for dengue. Now, if it is not the D for dengue, then it's by default that the Anopheles mosquito will be spreading the malaria. But I have a trivia for you. While a lot of persons are not responding, I don't know what I did wrong, but many persons are not talking to me today. So I'm going to be asking you a question. Is it fair for me to say that a mosquito is a vector? Anybody want to tell me that? Is it fair for me to say that a mosquito is a vector? All right, yes or no would be fine. Is it fair for me to say that a mosquito is a vector? Is it fair for me to say that a mosquito is a vector? Yes or no is Giovanni Scale. This person is new. New persons, please be reminded to like, share, and subscribe. Welcome to the show, Giovanni. I'm sure I don't know the name. So when I see new persons, I pick them. But I know everybody that comes to my show. Even when I have 100%, I know everyone. All right, so welcome to the show. All right, so some persons are saying yes. Norman Douglas. I don't know if I know that name, but welcome to the show. Please be reminded to like, share, subscribe, and check out the many other videos. We have 200 and something videos on the channel, 218. One must be there for you, or a couple must be there for you if you are doing biology or HSB. We have turned off all the IT videos that we have on the channel. So there are things there for biology and HSB, and of course, exam tips, past paper, labs, you name it, virtual experiment, and otherwise, they're all there. Welcome to the show. Welcome to the family. All right. So some persons are saying yes, some persons are saying no. Let me look at what the SOSA is saying here. An organism, typically a biting insect or ticks that transmit a disease are parasites from one animal or plant to another. But I want to know if the vector is affected by this disease that is being transmitted. So, yes, you're telling me that, but we need to have this clarity as to whether or not the vector is affected. So let me just hop on back to these questions and these answers here. I'm going to randomly choose some persons to help me with the answers. So I'm going to ask Douglas to tell me why yes, and I'm going to ask Cheryl to tell me why no. All right, so both persons are going to defend their point. The question is Is it fair for me to say that a mosquito is a vector? Some person said yes, some person said no. Now, I want to know why yes or why no. And at the same time, I'd also love to know if the vector is affected by the disease. Are you ready for those answers? Let me have them as soon as you are ready. So other forms of vector would be like the housefly, which is of course responsible for gastroenteritis. All right, so the disease there is gastroenteritis, and you have like rats. I use rat primarily because rat is so popular with HSB and leptospirosis and storerooms. I know I've seen questions with rats and storeroom, so I thought it was very, very good for me to bring leptospirosis. And just to talk a little bit about leptospirosis, while you answer the questions I've asked, I know of a story where a young man in rural Jamaica ate a soursop that was bitten by something. He was not aware of what it was bitten by, whether it was by a bird or by a rat, but he ate the soursop. And can I tell you what happened? We wished him well. We wished him well. Thus to say, if you're a lover of fruits and all of those stuff, make sure that they are properly washed, properly clean before you eat them, because you might be exposed to any of these. You could be exposed to gastroenteritis, or you could be exposed to leptospirosis. Now, I realize that no one is answering my questions. So I will just answer them for myself, being that it's a lonely day for me today. All right. So the vector is not affected by the disease, right? The vector is not affected by the disease. The host is affected, all right? So the vector is not affected by the disease. Now, another question I am supposed to answer is it fair to say that mosquitoes are vectors? No, it is not fair to say that. And I'll explain why. The male does not suck blood. All right? The male tend to feed on the juice from plants. So if the male is not sucking your blood or the animal's blood, right? And being in a position to move the pathogen, and we're saying that the vector moves a disease or move the pathogen from one place to another. Uh, if a male is not doing that, then we cannot consider the male to be a vector. Only if the male is doing that. So understand that in order. So the vector thing with mosquito, as it were, for blood and moving blood from person to person, it is the female, not the male. We are innocent this time. For the first time in our lives, we're innocent. This problem, this transmission of dengue and malaria, it is because of the women. It is, of course, the female that's doing that transmission. That we needed to have clear before we move on. Thank you, sir, for those answers. I should be saying thanks to you. All right, so we move on. And like I said earlier in the show, that the Aedes aegypti mosquito is the mosquito responsible for spreading dengue. It's a mosquito responsible for spreading dengue. And we spoke about yellow fever, and person might talk about chickpea, zickpea, that type of a thing. And we also said that the Anopheles mosquito is responsible for spreading malaria. Now, there's something I want to bring out here based on what we did in the last class. The pathogen, as in the case of dengue, that the mosquito transmit, is it a virus? Is it a bacteria? Is it a fungus? Is it worm? Is it a protozoa? What it is? What really causes the disease? What's the agent there? The disease causing agent. What's the disease causing agent there with dengue fever? Tell me in the chat. And while you type in the chat the agent that causes dengue fever, remember that mosquito is the vector. But what agent causes it? The other thing I want you to tell me in the chat, what's the agent that causes malaria? Yes, the mosquito carries the pathogen. The mosquito is the vector. But what is the, all right, so Barnett is saying that the causative agent here is going to be a virus. Is there anybody who is agreeing with Barnett? Amoy, what are you answering? I am not too sure. I'm not too sure. What's Plasmodium for, Amoy? What's Plasmodium for? I'm assuming that virus there was for dengue. I'm assuming, I'm not even sure, but you could tell me if the virus is for dengue or is it that the virus is for malaria? So the virus, you have to answer both at the same time, or else I won't know what you're answering. So is it that the virus is for malaria, or is it the virus for dengue? Is it that Plasmodium is for malaria, or is it that Plasmodium is for dengue? I want to know that sort of a thing. We have to have it all right before we move on, right? So we're going to be spending a whole lot of time trying to identify these mosquitoes. We're going to spend a whole lot of time looking at that. All right. So while I wait on the answers from all the persons in the room, I just want to remind you that the Aedes aegypti is also called the tiger mosquito. And it is called a tiger mosquito because it has white stripes, white bands on the body and on the leg. Now, another thing that is typical about this particular mosquito is that it is like this urban mosquito. Town. It loves the town, want to be in the town, because there's drain and, water, stagnant water all over the place. All right, so let me see what's happening here. So Barnett is saying Plasmodium is for malaria. Amoy is saying Plasmodium is for malaria. Very good, guys. And please be reminded that Plasmodium is the name of the particular causative agent, right? But what is the Plasmodium is an example of the causative agent. But what is the causative agent? If you are going to say virus, we could talk about HIV as an example of virus, right? But if you say Plasmodium, yes, Plasmodium. But of the group of things that we said that would be causing a disease, which one would we place Plasmodium in? Which are these groups? All right, so it's virus for dengue fever. That's fine. All right, but we talk about Plasmodium now. All right, this is an example from the group. Now, what is the name of a group of organisms to which the Plasmodium belong? Very good. Protozoan or protozoa. All right, so that's what I was looking for. Now, for those persons who are doing biology, you might have heard about trichonympha. Trichonympha is the protozoa that is found in the gut of the termite that eat the wood, and it is actually the trichonympha that causes the termite to be able to digest the cellulose there in the wood. So here we are looking at protozoa. Here it is Plasmodium, and I did make mention of trichonympha. For the greater part, you've been hearing about protozoa. Everybody can talk about a virus, identify bacteria, identify worm, but usually there's a little problem with protozoa. We spoke about trichonympha, and here we are talking now about Plasmodium. And as we go through the lesson, I will continue to highlight these things that we're supposed to remember. All right, so here we go again. So we said that the Aedes aegypti mosquito is this town mosquito, urban mosquito. And to identify, one way in which we can identify it is by the white stripes, black and white ring stripe, pretty much like the tiger. So they call it the tiger mosquito. Now, it is very important to note that it's the female that is actually responsible for the spreading of a pathogen. as in the case of the dengue and the malaria. They do so as they are in search of blood, and they are in search of blood because of its high protein content that they require to feed their young, or they require to ensure that the species continue, like food. All right. Now, another thing about the Aedes aegypti is that it tends to love stagnant water. And here, I will have to come again and make clear some things when I give you some of these examples. Now, stagnant water would be the water in the pothole or that rut on the road, in that pond somewhere, in that food box, that plastic bag. It could be in a plant on the outside for some time. It could be in your flower pot. It could be a swamp, down the road, or it could be in the drains and that type of a thing. All those could be, of course, stagnant water. And of course, they use the stagnant water for the egg, the larvae, and the pupae development. All right. So I want you to look at the word pond, because when we talk about the treatment and cure or prevention, and we're going to be talking about using oil, I want us to be very, very careful with where we apply this oil, because this pond word is used loosely, and from time to time we tend to forget that there are other life forms in ponds, and when we use this oil, we could, of course, damage those life forms. Now, another thing I said earlier is that it is a town mosquito, and why it is really a town mosquito are found mostly in town areas is because of the drains and the gutter and the garbage that is usually at a higher density in these areas. So it is more likely to have this breeding ground for the mosquitoes. So the Aedes aegypti really strive in these areas. Now they lay their eggs in what we call, the eggs are laid in pretty much singles. All right? Single. And of course, they are laid in the water, and we could say that they are pretty much laid in singly. Put it nicely, they are laid singly on the film of water. All right, just singly, 1, 2, 3 on the film of water. All right, and there the egg will stay and develop. Now, the egg will stay there and develop after about 4 weeks into what we refer to as a larvae, right? And the larvae is usually held, should I say, I don't want to say upside down, but it is held with the breathing tube connected up to that film of water, as the breathing tube through this area, or through the spiracle. The breathing tube is connected to the water for breathing, while the larvae will filter the water to get food from the water. And these food material are things that are floating, passing by. Some are so small, but of course, they are enough for the larvae to eat. So what we know is that the egg, this part of a life cycle, is found in water. Larvae, this part of a life cycle, is also found in water. Now, one might ask if the larvae, if they are able to move. Now, everybody who would have seen mosquitoes in water, or the larvae in water, you know that they will flicker the abdomen or flick the abdomen in order to propel themselves or to move from one place to another. So the larvae state, this is a takeaway I want you to have. The larvae state is feeding. The larval state of the mosquito, it is feeding in the water. It is breathing in the water. However, when we get to the pupa state, that state does not feed. The pupa state, that state just does not feed. And again, the movement of the pupa state is pretty much by flicking the abdomen again. Now, it is also able to breathe through what we call air tube, which is, of course, also connected up to the film of water there. So you understand that though these organisms are in the water, they are able to breathe by the special tube that they collect air through that is pretty much right there at the surface of the water. At this stage, I think I said something about a larva taking place 4 months. It's pupa stage. The pupa stage takes place about 4 months thereabout after the egg would have laid. Not the larva stage, the pupa stage would have taken place about 4 months thereabout after the eggs were laid. So we're looking at the life history now. You could say that we're looking at the life cycle of the mosquito, and the first 4 phases are 3 phases that you've learned of so far. I think we did 4: the adult, egg, larvae, pupae. So we can say now that a mosquito has a complete metamorphosis. Now, things like flea, they have incomplete metamorphosis because the mosquito has egg, larvae, pupae, adult. Egg, larvae, pupae, adult. Now, the egg completes its development in water. The larvae completes its development in water. The pupae completes its development in water. And the adult, you can say where you'd find the adult. Now, the adult, let me just do a little bit more about the pupae. In the pupal stage of the mosquito, during this time, you can see or you can detect things like the legs, the eyes, that type of a thing. This is pretty much a stage that you can start seeing these things. All right, and at that stage, you tend to coil somewhat in a little C-shaped thing, with like a big head, that type of a thing. You can identify thorax and so on in this stage. So remember, it's the pupal stage that feeds. Did I say that? Am I correct? Which stage feeds? Is it pupae or larvae? Is it pupae or larvae that feeds? Tell me. I think I've been talking a while ago, and I think that I am the only person in the class. All right. Which stage feeds? Is it pupae or larvae? Tell me in the chat. Which of the stage would be feeding? Would it be pupae or would it be larvae? Would be feeding. Would it be pupae or would it be larvae? Tell me in the chat. Oh, wow. Some persons are saying larvae, some persons are saying pupae. Very good. All right, so let's get that right again. The larval stage is the stage that would be feeding. The larval stage is the stage that would be feeding. All right? The pupa does not feed. All right? It's the larval stage that would be feeding. All right, very good. So after we have egg, comes larvae, pupa, then comes the adult. And what will happen is that the pupae will start having an opening at the back of the head there. And from that will emerge the adult mosquito. The adult mosquito will emerge and come to the surface of the water or the film of the water. And while it is there, the cuticle will become hardened and the mosquito is able to fly, move about, and start causing trouble for you and I. So we spoke a little bit just now about the life cycle or the life history. You could say the life history of a mosquito or the life cycle of a mosquito. All right? We could say either of those. All right, so here we go. So remember, we start with the egg, and the egg is laid singly, pretty much on the surface of water. Then we have the larvae, and the larvae, some of the things that you'll see with the larvae is the breathing tube. You will also be able to see the head and the abdomen. You'll be able to see the thorax, mouth, and the mouth have some things we call brushes. All right, another thing is that for the pupae, you'll be able to see the breathing tube, the abdomen, legs, eyes, and possibly wings. And then we have the adults. All right, good. I do hope we have that all correct there. Now we want to look at something else. We want to look at the difference there is between the Aedes and the Anopheles. All right. So tell me one difference that you know about the Aedes versus the Anopheles. One difference that you know about the Aedes versus the Anopheles. One difference you know about the Aedes versus the Anopheles. One difference. So share it with me. I'm waiting on you. One difference. Type it there in the chat for me between the Aedes and the Anopheles. What's that mean? I'm not seeing anything. I realized something just now. Had me pause there for a while. All right. Pupa is non-feeding. Anopheles transmit. Anopheles transmits malaria, and the malaria is caused by the plasmodium. Uh, but you didn't tell me what's the difference. You said one thing. What about the other mosquito? Christopher, one give dengue. That Christopher, I think you're new. I'm not seeing you. Welcome to the show. I've not seen you before. One give dengue. We can't say one. We have to name the mosquito that causes dengue, and then we continue by saying while the other. All right, while the other. All right, and then the SOSA, Anopheles, when biting will give, when bitten, sorry, will give malaria. But I'm asking for one difference. I don't see anybody giving me any difference. You're telling me what one will do. But if it's one difference, you need to tell me what the other will do. All right? You can't just say one thing. Where difference is between two things. Difference could be at least between two things. All right? So you can't just say one and leave it there. All right? Aedes transmit virus. Somebody not getting it here. Good evening, Ransom. Oh no, oh no, no. All right, let me just slow this down. Because if you wrote that on an exam paper, you'd get 0 for it. The question is for you to name at least one difference between the Aedes versus the Anopheles. So the one difference could be that the Aedes transmits dengue, while the Anopheles does not. Or the Aedes transmit dengue, while the Anopheles transmit malaria. But you can't just say the Aedes transmit dengue and leave it there. So how would we know what are you comparing it with? So you have to make reference to both when you answer the question. All right, let's move right along. So when we look at the differences between Anopheles and the Aedes, the first thing that should come to mind is that the Aedes transmits dengue, while the Anopheles transmits malaria. The other thing is that the Anopheles mosquito, the eggs is on what we refer to as an air float. Some might say a raft, right? While the Aedes, it doesn't have its eggs on this raft, this air float type of thing. Now, the Aedes, however, the larvae tend to hang perpendicular to the water. So the water would be like that, and the Aedes, the larvae, would hang something like this, right? Perpendicular. However, the larvae of the Anopheles tend to lie parallel. So it will be this way and not this way. So it tend to lie this way. All right, the Anopheles, the larvae lies in the water parallel to the water, while the Aedes is larvae lie in the water perpendicular to the water. Now let's continue. Now when we look at when these mosquitoes perch, or one might say when they settle, now the abdomen of the Aedes is parallel to the resting place. It is parallel, so if this is the resting place, it's going to be parallel to it, running in the same direction, or the abdomen might be lying on the resting place. Now for the Anopheles, when it perch on the resting place, what will happen is that the abdomen will be upward. So the abdomen is not down in the case of the Anopheles. When it perch, it tends to have the abdomen up in the air. All right. Now, another thing that we can recall about the Anopheles versus the versus the Aedes is that the Aedes tend to be black and white, while the Anopheles is usually black. All right. So a lot said there about the differences between the two mosquitoes. Remember that you have to read. Aedes is black and white. The Anopheles is Barnett. I don't know that color that you have there. I can't remember seeing a mosquito with that color. Look at what you wrote, Barnett. Other persons can't see, but I can. All right. So we made that distinction there. Remember, you can go back to the video while they're on the set to find out more about the mosquito. All right. So we move on with the mosquito as a vector, and I'm going to be talking a little bit more about a mosquito. All right. So the first thing we know is that the female has what we refer to as antenna, and on the antenna you tend to have some little things like it's sort of bushy, or one might say a little fluffy, right? For the female mosquito. As it were, for the male, the antenna is more like a thread, right? And of course, the males can't suck blood, all right? And because they're not sucking the blood, then we say that they are not really vectors. Now, it's the female that is attracted to people, and they're attracted to people because of the sweat, right? One thing we're going to find out is that there are some persons who might think that they are not affected by mosquitoes, but they are, and I will explain why. Now, the mouth part of a mosquito is held in what we refer to as a labium. All right, the mouth part of the mosquito is held in what we refer to as a labium. And it's important to note that the mosquito sucks blood through a tubular mouth part. So the mouth part is like a tube. So having pierced the skin, it can pretty much just pull up blood in that mouth part. But this is where we might be having some question. When that mouth part gets into the skin, the mosquito also send down some saliva. And the purpose of the saliva is to prevent the blood from clotting while it's coming up to the mosquito. Now, there is some ill effect, as it were, with this saliva that has been injected into the skin. Now, if the mosquito has the pathogen, bear in mind it's not all the while the mosquito have these pathogen. If the mosquito have the pathogen, that is when the pathogen gets to invade the body of the host. Now, the saliva will also cause some amount of irritation. The saliva will also cause some amount of irritation. But nonetheless, we spoke about COVID the last time around and some immunity stuff. Once a mosquito would have secreted that saliva under your skin, then naturally the body is going to send some antibodies there to treat with it. Now, while the antibodies tend to treat with it, the area where you were bitten will, of course, scratch you. Some person would say, I will have some irritation around that particular area because the antibodies, they are dealing with this foreign content that was introduced. Now, you should not scratch this area. You shouldn't go scratching the area. And the reason you shouldn't go scratching this area, it is because you might introduce pathogen, bacteria to this area, it become infected, and then eventually a sore, and you end up with a scar that you really didn't need to have. All right? So avoid scratching whenever you are bitten by a mosquito. Some person might say that it is difficult, right? But as much as possible, try not to itch. All right? Now, control of mosquitoes. That's where we are now. We want to look at how we control mosquitoes. And I am going to listen to you while you tell me about the many ways to control mosquitoes that you would know. So tell me very quickly, what are the ways in which you could control mosquitoes while I try to revisit something I said earlier. I think I said something, but I'm going to revisit what I have to see if that's actually what I said. All right, so tell me in the chat while you go through what you know about mosquitoes. Tell me what you know. I am looking. What's that mean? Nobody know how to control mosquitoes? That can't be. All right. Fish can be placed in ponds to eat the stages that are in the water. Killing adult mosquito with insecticide spray. Very good. Would you say that the insecticide spray cannot kill the other stages? Because it's very, very important that you understand what we use to control all the stages. So would you say that the insecticide will not kill the other stages in the water? Uh, Wash flower pots regularly, that's a good one. Drain stagnant water, that is another very good one. Continue. Somebody say killing adult mosquito with insecticide. Removing dense vegetation and remove adult protection. I'm not too sure what that means. You can control. Mullins, welcome to the show. Please be reminded to like, share, and subscribe. mosquito by putting oil on top of water that they are, well, I want to address that one, Mullins. We have to talk more about that. Some might say fogging, where I think they use malathion with this eye compressed thing and you get the smoke effect. You could fog, and that's, of course, another method of insecticide. Measure to control mosquito. Don't keep water in uncovered container. That's a very good one. Drain all areas of standing water. Rid debris that can collect water. Yes. Spray insecticide and kill adults. All right, continue there. I'm looking for some others that are not there. I've heard a lot, but there are some others I'd love to hear. All right, so keep telling me. And eyes up. All right, so somebody said put cooking oil. All right, I want to address this whole idea of oil and water. If you are going to be placing oil and water, you have to make sure, see, that we don't have any other organism in the water that we will harm. Hence, placing oil in water, it must be in some regular container around the house or somewhere that you know that no other organism will be affected. We don't want to just go out and just because we're trying to kill mosquitoes, we kill all the other organisms or remove all the other organisms from the planet. We really don't want to do that. All right. So I'm going to tell you, I was looking for the biological control, BT, Bacillus thuringiensis. So you can use insecticide like fogging to kill adults. There are insecticides that will kill adults. You could, of course, use oil on the surface of stagnant water. Now, what the oil does is, of course, to reduce the surface tension of the water. The physics person can explain more on that. Now, after that, what will happen is that the larvae, they will sink. They'll be under the water, they won't be able to get any air, and they will suffocate. The same will happen for the other stages, the egg and the pupa. They will sink below the water or sink below the oil. They won't be able to get any air, and then eventually they'll die. Drain stagnant water. If you drain stagnant water, you will disrupt the life cycle of both egg or the development of both egg, larvae, and pupae. Another thing is that you could introduce some fish in the ponds that are pretty much ecosystem for other organisms, like gopi and all of that. Those little fish, they will, some persons call them tiki tiki and so on. Those fish, they will eat the larval stage and in some cases the egg of the mosquito, causing the mosquito to die. Now, if you break the life cycle and the adult is not able to get any blood, then the development of the young is definitely going to be impossible. So as adults, as human, we need to wear protective clothing, long sleeve shirt, pants, that type of thing, so that mosquitoes won't be able to access our blood that easily. We want to wear, of course, put mosquito net over the cribs, at the windows, so on. And we want to wear things like repellent that are made of DEET, that type of a thing, to ensure that the mosquitoes stay at bay and won't be causing any major problem. Now, there's another thing. This is a biological control, and it is very important for you to understand how is it that you control each stage of the life cycle. How do you control the egg? How do you control the larvae? How do you control the pupae? How do you control the adult? You need to know that. Now, there is a biological control, and you remember from the ecology aspect of biology that the biological control speaks to using one organism to control another. Here we are using a bacteria, Bacterium bacillus, or one might say Bacillus thuringiensis, and they just use it. You don't have to remember that fancy term. They use BT, but on the multiple choice paper you will see Bacillus thuringiensis. All right, so Bacillus thuringiensis is of course a live bacteria, And how it works is that it is placed in the water. Now, the larvae, what stage? The larvae will feed on the bacteria, and as it enters the stomach, it will multiply, or one might say that it will reproduce. Now, as it reproduces, it will, of course, kill the larvae, and having killed the larvae, and the inside of the larvae become exposed because it bursts or otherwise, the replicated bacteria will now be in the water, and then other larvae will eat it, and then so the organism will continue to die, continue to die, continue to die. So the biological control, or one biological control for mosquito, is to use Bacillus thuringiensis, or BT, as it is called, and of course it is a bacteria. All right. So it takes me to the point where I want to ask you some questions. Now, I have been thinking in my head, if I told you that the pupa took 4 months or 4 days, I've been thinking about that. You can correct me in the chat if it was 4 months or 4 days, but now I'm giving you something to write in the chat, right? I want you to tell me in the chat. After this, the chat comes below the video here. You'll see comment. You're going to leave a comment. I want you to tell me how long is the mosquito's life cycle. And I want you to also listen to the video and tell me whether I said 4 months or 4 days for the pupa. I don't want you to answer it now. I want you to put it down there. Let me see how many persons are listening, how many persons are actually entering information in the comments. We know they come to us now. Remember, when you put it in, we see it. Yeah, it come. I know that everything that Barnett what she leaves a comment. I know that Amoy not leaving any comment. All right. So please leave your comment after the show. Go down below the video you are watching down. You will see comment, and just write what you think about the show, or what, I don't know. I'm not going to tell you what to write. I remember to give a thumbs up. Where you see the two little hand like this, one go down and one go up. Just click the thumbs up, right? And you also want to ensure that you continue to share it with your friends, so your friend can share with their friend, and their friend share with their friend, and the sharing and the sharing and the sharing and the sharing continues. And then, if you have not yet selected or clicked on the notification bell, even though you are a subscriber, you will not know when I have new publication. So you have to go there, the notification bell, click again and subscribe, go to the notification bell, or if you have a bell beside it, I think you might have a bell beside the subscribe button, and click on that button. Now, just a little lesson for those persons who are not so savvy with YouTube. And trust me, most persons are not savvy with YouTube. We can find a video on YouTube, but most persons can't find a channel on YouTube. And I have discovered this through teaching students, and I ask them to access different things. So when you are watching YouTube, to the top right-hand corner there, for some videos, you'll see a little round white dot, a little white circle with like an exclamation sign on the inside. Now that gives you the suggested video that comes up next, right? So we might think, having done a show, it's wise for you to watch this video next. If you click on that up there, you can get the next video. Usually it pops up on the screen, but if you want to see, you could click and you could see. Now at the end of the video, you will also see 2 or 3 or 4 videos that comes at the end of the video. If you are watching a video, you can click on any of those to watch a video. If you are watching the video and you want to subscribe, there's a yellow square at the bottom right hand corner that says CSET Biology TCP. You could click on that and subscribe, or just below that, the video, there's this red button that says subscribe. You can click on that button and subscribe as well. But remember, to subscribe, you need to have a channel, or you need to have a YouTube account, not a channel, just a YouTube account. And to get a YouTube account is like to sign up like for any email account, all right? And it works for you now that we're having COVID and a lot has been done online. A lot is been done online. Pretty soon a lot will change, because so what will happen is that some of my videos will be on my website and only some will be on the channel. And some of those videos that will be on the channel, if you are not a subscriber, you can't see them. All right. And it might just be one of those videos that you're looking for CSEC. Remember, we write for the regional exam. I am writing script for CXC, so it would be specific towards the syllabus. So it's not like just watching a video on anything. We know that we're creating for CXC and we make sure that that is there, that you don't have to go all over the place to study. All right. So it's going to be that for the show for this evening. We looked at the life cycle of the mosquito. There were a lot of takeaway from this lesson, which will require you to watch the lesson again and make notes. In our next show, we are going to be looking or digging deeper into malaria and dengue fever. We're going to be looking at causative agent. We're going to be looking at signs, symptom, prevention, and possibly control. All right. You will see me talking again about another type of anemia. We spoke about two anemia in the class that went by. We're going to talk about anemia when we look at malaria. We're going to talk about anemia again. And you're going to find that there are many things that could lead to anemia. All right. So, like I have said, make sure that you go on over and watch your past papers while they are there. And make sure, of course, you are sharing with everyone. Remember that the exam is just 2 months away and you can't afford to fail. Failure is not an option. All right. So thanks so much for stopping by this evening. All the best. Take care.